In a previous video, I described how to use a scatter plot to determine the relationship between two variables. Scatter plots can also be used to determine the strength of the relationship. Next, I will explain how to measure strength. Correlation coefficients indicate how closely two variables are related and give an indication of the strength of a relationship. The correlation notation is R measures the direction and strength of the linear relationship between two quantitative variables. Now, how do we calculate R? This is the formula for the R, the short form. R equal 1 over n minus 1. N is the number of points. Summation xi minus x bar over sx times yi minus y bar over sy. X bar and y bar are the average of x and y respectively. Sx is the standard deviation of x and sy is the standard deviation of y. Now let me explain an example. Find the correlation coefficient of the following two variables. There are two variables x and y and 5 points. What is the first point? 51, 11. The last point 70, 17. Right. How do we calculate R? Use the formula. What do we need? We need x bar and y bar. And also we need standard deviation of these two variables. How do we calculate the standard deviation? Using this formula. I explained this in a previous video under chapter 2. We can use x values for the sx and y values for the sy. Then what do we need? We need n. N is the number of points. How many points? 5 points. Now we can plug these numbers to the formula. Then simplify. R is 0.991. What is the meaning of this? This is the positive relationship. Why? Because R is positive. Therefore, x and y has a positive linear relationship. And this is very close to 1. It is 0.991, which is very close to 1. That means this relationship is very strong. Yes. Correlation makes no distinction between explanatory variables and response variables. R has no units and does not change when we change the units of measurement of x, y or both. Suppose x has unit as a miles and y also in miles, but R has no any units. Positive R indicates positive association between the variables and negative R indicates negative association. The correlation R is always a number between negative 1 and positive 1. R can be taken any value between negative 1 and positive 1, including negative 1 and positive 1. Correlation requires that both variables be quantitative. Correlation does not describe curved relationships between variables, no matter how strong the relationship is between them. Yes, it is also very important. Correlation is not resistant. R is strongly affected by a few outline observations. Correlation is not a complete summary of two variable data. Now let me explain using scatter plots. You see this one, all points are on the line. That means this has perfect positive linear correlation. Here R equal 1. Why? All points are on the line. So how about this one? A few points out of the line, right? Maybe this very close to 0.9. So we can say strong positive linear correlation. Okay, how about like this? 1 point very close to line, right? So weak positive linear correlation. Maybe R close to 0.4. That means when R get close to 1, we say it has a strong linear relationship. But when r getting close to 0, we say it has very weak linear relationship. But this is only positive. How about the negative part? It is the same but other direction. Right. Now let me consider this, the middle one. Here, top one, R has a positive linear relationship. Why? R value is 0.9. The below one, R value is negative 0.9. It means it has a negative linear relationship. So which one has the most strong relationship? Actually, R value indicates the strength. Therefore, here value is 0.9 for both cases. Therefore, both has the same strength but different direction. Right. Now go to this type of. What can you tell about here? Here, no linear correlation because R equals 0. As I mentioned before, using R, we can understand only linear relationship, not non-linear relationship. If R equals 0, that means there is no linear relationship, but maybe non-linear relationship. Okay, therefore R equals 0 indicates no linear relationship. Now let me explain another example. Find the correlation coefficient of the following two variables. Yes, we discussed this example before. So R was the 0.991. Therefore, we can say it has a positive linear relationship and very strong linear relationship. Suppose we have some data. How many points here? There are 3 points. It is given that the standard deviations of x values and y values are 1 and 1.53 respectively. Calculate the correlation coefficient. Yes, first write down the given information. There are 3 points. Therefore, x values are 0, 1, 2, y values are 0, 1, 3. Then, standard deviations are also given. Now, go to the formula. R equal this. And we know n. What is the n? N equal 3. And x bar? Yes, need to find the x bar. It is 1. Y bar? Y bar is 4 over 3. Now, we can plug to the formula. N equal 3, so just plug the numbers. The answer is 0.98. Again, this has very strong linear relationship and x and y has positive linear relationship. Okay, so you can draw something like this, strong positive linear relationship or linear correlation.